All right, number 10. What is the vertical intercept of the quadratic x plus 2 times x minus 3? Write your answer as a coordinate pair. So see what I've done here with these two. On number 9, I specifically on purpose gave you a quadratic that was in standard form so that you could factor it and show me you know how to factor it and get the horizontal intercepts. And on this one, standard form is the best for finding the vertical intercept when x equals 0. And I gave it to you in factored form. So I'm going to see if you can multiply these two things together. I'll tell you what, it's probably the easiest way to find the vertical intercept. Let's quickly think about this real quick. I'm going to go over these axes again because so many people think that this quadratics is about memorizing a bunch of different stuff, but it's not. It's about understanding what a vertical intercept really is. If you understand this stuff, there's no need to memorize a bunch of steps. Vertical means straight up and down. So what are we looking for when this graph crosses that green line? I've highlighted my vertical axis, the y-axis. This is where x equals 0. Any point on this line, x equals 0. That's what our vertical intercept is. So we just got to plug in a 0 for x's and find out what y equals. So let me maybe we'll go with a blue pen here. I'm going to say y equals, take your formula, x plus 2 times x minus 3, and then all you got to do is swap out those x's for zeros. Honestly, you could multiply those together and get your standard form, x squared minus x minus 6, and that would give you your answer. It'd be negative 6. Or you plug in 0 like this, right into those factors. And you know what you're going to get? You're going to get y equals, the 0 plus 2 is 2. 0 minus 3 is negative 3. Y equals negative 6. Now, please write this as a coordinate pair for me. Show me you can write this as a coordinate pair. We know what y equals when x is 0 now. So let's put it together and write it like this. When x is 0, y will be negative 6. And that is our vertical intercept right there on the y-axis. When y is negative 6 and x is 0, here's what our answer looks like. So like I said, plug 0 in for both of those x's, or you could make a square, multiply them out. X plus 2, x minus 3. X times x is x squared. We got negative 3x. Negative 3x. And 2x. And what's the most important part here that's done here? There's a negative 6. There's our constant. When all these x's turn to 0, I guess the only thing that's left is that negative 6. So that's why we like standard form. Because it does help us to find. What is going on here? There we go. There's your quadratic in standard form. You don't have to do everything that I've done here. I'm giving you different options to do what you like and help you understand what's going on here. You could plug in 0 for the x's here, do the math on that. You're just going to get this times that. You could multiply them all out, and then when all these x's turn to 0, all you got left is that negative 6. So just remember, if you're looking for the vertical intercept, you want to know when x equals 0. On question 9, when you're looking for the horizontal intercepts, you're looking for the two x values that make y equal to 0.